Okay, if you're watching this video, you wanted to see a little bit more detailed explanation for the two graphs that we didn't talk about in the previous video. So here we go. I think finding the pieces of information you should be okay with, so go ahead and do that if you haven't already. So let's talk a little bit about how we form the cosecant curve. I want you to think about your sine graph first. So we know sine begins and ends, and halfway will be on the midline. It'll be up at its highest and lowest points like we see here. So I'm just going to dot in our our sine graph. The cosecant graph takes any midline points, turns them into asymptotes, and takes those high points and turns them into like the vertex of that little parabola type shape, and does the same thing with the low points. So when we're looking at our cosecant curve, we know we're going to start and end with an asymptote. Halfway through, we're going to be in an asymptote. And then in the middle of the asymptotes, we're going to see a parabola that points up and then a parabola that points down. Okay, so that's the general idea for how we would graph a cosecant curve. So just like in our previous videos, I'm going to start with the amplitude. Sorry, not the amplitude, the midline, which is at y equals 0. All right, so we have our midline here at y equals 0. Now, we're going to shift everything left 3 pi over 2. So we can do that right now. We can start, and we know that we start with an asymptote. So if we shift everything left 3 pi over 2, this is the beginning of the first cycle, and it's going to start at 3 pi over 2 with an asymptote. Now, here's what I know. I know that the period length is 3 pi. So what I need to figure out is how many spaces does it take to get 3 pi, or even 1 pi, and then just multiply it by 3. So looking at my graph, it looks like if I count 1, 2, 3, 4 bold lines would give me 1 pi. So I'm going to need to do 1, 2, 3, that's 1 pi. 1, 2, 3, that's 2 pi. 1, 2, 3, that's 3 pi. Okay, so that's going to be the end of a cycle here at 3 pi over 2. So I'm going to go ahead and put that in there. That is an asymptote. Now, halfway between the beginning and the beginning and end of the period, we're going to get another asymptote. So I've got that at 0. And now I can start thinking about putting in my high vertex and my low vertex. Remember, this represents the start and this represents the end of the cycle. Okay, so halfway between the start and the middle, we're going to be up at our higher vertex. So we have to figure out, what's halfway between here and here. So count the number of darker lines. 1, 2, 3, 4, 5, 6. Cut that in half. 1, 2, 3. So we're going to put our higher vertex point here at negative 3 pi over 4. And it only goes 1 unit above our midline. And then we're going to do the same thing over here because we need to go halfway between here and here, and it'll give us our low vertex point. So once again, count 1, 2, 3, 4, 5, 6. So we're going to cut that in half, 1, 2, 3, and our midline, below the midline, will give us our amplitude or our vertical stretch right here. So I go ahead and put that, and I've got now the high and the low points of those vertex type shapes or parabola type shapes. Now what I notice is that if we look at each piece of the graph, so between the asymptote and the high point is 3 darker lines. Between the high point and the asymptote is another 3 darker lines. Between this asymptote and the next point, we have 3 darker lines. And we have 3 darker lines here. So I know that 1, 2, 3, here something's going to happen. Now, it's not going to be an asymptote. That'd be too close together because they're spaced 6 spaces apart. It's not going to be a low point because then we're not seeing that oscillating type behavior. So I know that 1, 2, 3 places, I'm going to go actually up and graph a higher vertex point. So that'll put me right there. I don't really have any space to do anything else. So at that point, I'm just going to sketch in my graph, right? So I'm going to have these sort of parabola type shapes in between the asymptotes. And then this was, really similar to the photo that you saw on the previous video. Let's go ahead and talk about that tangent graph. All right, so last one. Once again, go ahead and fill all the characteristics in, and then come back and we'll talk about how we graph it. All right, so you should be able to, again, once you get all of the information for the graph. We've spent some time with that in the previous video and previous Go Formative. But let's go ahead and talk about our tangent graph. So the tangent graph is going to start with a midline point. Now, just like every other function, that we've talked about with these. It's going to end the same way it started. Halfway between the beginning and end of the period, we're going to see an asymptote. And then we're going to see it go to its highest point and then its lowest point. Now, when I say highest and lowest points, I'm talking about the amplitude, okay? So this is going to be controlled by the amplitude. And then what we'll see is that pattern will repeat and we'll be able to fill in our graph. So we start with a midline point and we end with a midline point. Halfway through, we get an asymptote. And then we're going to go up to our highest point using the amplitude and then down to our lowest point using our amplitude. So let's go ahead and start with the midline at y equals 0. Now, I'm going to go ahead and continue to graph using my phase shift next. I know that we are shifting everything right to pi. So I'm going to think about this as being the start of my cycle. So what I know is that we start at a midline point. So that would be a midline point right here. Now, I run out of room if I try to go to the right. Okay, my problem is there's just not enough space on the right of that starting point to really figure out what that cycle is going to look like. So here's what I'm going to do instead. I'm going to think of that as not the start, but remember, every starting point is also an ending point for a period. So this is the ending point of the period that came before it. Now, what I have to figure out is where did that period begin? So I know that it's 3 pi over 2 units long. That's the length of the period. Well, on my graph, 1, 2, 3 of those darker lines, this length represents one period. So I know that if this is the end of the period, it had to have started 1, 2, 3 of the darker lines prior to that. So this is where the beginning of that period would have been. Now I'm going to go ahead and fill in kind of the beginnings of all of the periods. All right, so now I've got, this is the beginning. It's a start. It's also an end, okay? But I'm going to go backwards now and fill in some more of those beginnings and ends of the period. So 1, 2, 3 lines is going to be another start to a period, and I'm going to keep doing that. So then we have 1, 2, 3 lines would be the start of another period, and then I run out of room. Okay, so I'm going to just stop there. Now, let's focus on this period here, the start and end being right here. Now, here's what I know. Halfway between the beginning and the end of the period, I'm going to be at an asymptote. So if I look at halfway between here and here, so that's 1, 2, 3 darker lines. So I'm going to have to cut that in half. That's 1.5 darker lines. So my asymptote's going to be right here. So I'm going to go ahead and put that in. And now what I know is that's going to be the case for all of these, okay? So for every single set of beginnings and ends, halfway through, I'm going to have my asymptote. So I'm going to go ahead and sketch those in. And those are going to be 1.5 spaces from either of the endpoints of the beginning or end of the period. Now, what I can do is I can also get that in right here. And I might even be able to get that other asymptote in on the right. I can. Okay, so I'm just putting in all of my asymptotes at the same time. Now the pattern has us going up to our highest value. Remember, here's our start right here, okay? We're starting here. Goes up to our highest value first. Now that's just using our amplitude. So we're gonna have to look at between this midline point and this asymptote. Now, you can count the smaller lines here. So what is that? 1, 2, 3, 4, 5, 6 lines. So we're going to go 3 lines. 1, 2, 3. That means right here, we're going to be our highest point. And that's just using our amplitude. So we're going to go up 1 unit. And then we'll do the same thing to find the next point. So halfway between this asymptote and this midline point, we're going to be at our lower amplitude. So we go 1, 2, 3, and that puts us right there to get our lower amplitude, which is 1 unit below the asymptote. Now I'm just going to continue that pattern. Now remember, every ending is also a start. So I know I'm going to have to go 1, 2, 3 lines from every one of my midline points, and I'll graph either a high point or a low point depending on where I am in the cycle. So we know that moving from left to right, we see a low point first. So let me try that again here. And then a high point. And then again, in the period, for moving from left to right, we'll have a low point first, and then a high point. Now we've got enough information that we can sketch in our tangent graph. Okay, and again, it should be curved, not linear, so don't make these pointies, make them nice and smooth, and then you should have a nice little picture of what this curve will look like. All right, hope this helped if you wanted to see a little more detail on those two graphs. Again, keep track of any questions so we can go over them the next time we meet.